Right, we're just going to work through question 10 from the 2014 May Time Zone 1, Paper 1. One we didn't quite get around to completing in class, so hopefully this YouTube helps with this one. So I've copied, I've just snipped the question into my notepad here, and here it is. So the sides of a square are 16 centimeters in length, and here is that square. The midpoints of the sides of the square are joined to form a new square. So here we go, and we get 4 triangles, which we take a close look at. The process is repeated twice, and there it is in diagrams 2 and 3. X is the length of one of the equal sides of each new triangle. So one of the equal sides, that's X, and A is the area of each new triangle. Okay, so if we look at the first diagram, our 16 is chopped in half to 8 and 8. So if I go over here and draw that, we end up with, if we just look at, okay, there's our square inside. We start off with 16. These now become 8 and 8. And so what we want is, all right, so 8's here, the length of our first, when n is 1, when we've put in one square, when we've gone through one of those processes of putting a square in, joining up the midpoints of each side of the original square. I'm going through the whole thing because we're going to have to analyze this process, and especially as we get down to part C. Okay, so 8 goes in there. Now the area in here, right, that area is just a half base height, so a half times 8 by 8, 64, which is 32, and that gives us, that checks that box there. Now when we go into the second, square, now we're joining up these midpoints here, and through we go there. So now now this has been split in two, and I need to know what each of these lengths are, because it's this little triangle now that I want the area of, and I want the side length here. So this is my x2, and my a2 is 16, but we can get to that. I need to know what this is firstly. Now I can use Pythagoras to get this length here. So this length here is equal to, I'll call it d. D squared is equal to 8 squared plus 8 squared, 8 squared plus 8 squared. So that's 128. So d is a square root of 128, which is, that looks like 32 times 4, or even, so 32 times 4, so that's 2 root 32, but 32 can go to 4 eighths, in fact it can go to 16 too, so I end up with 8 root 2, and I could have got that 64 by 2 in here as 128, so that gives me my 8 root 2. So that length there is 8 root 2, so half of it is 4 root 2. So that's that length there, and that's what goes in just there, 4 root 2. That's my length of my new triangle that's been formed. Now I want the area, I want this area in here, which is, again, it's a right angle triangle, it's a half base height, so it's a half by 4 root 2 by 4 root 2, which is, if root 2 times root 2 is 2, 4 times 4 is 16, 16 twos are 32, times a half gives us 16. There we go, that checks. Now we go to the third triangle. I don't know if I can fit another one in here, but I'll have a go. 1, 2, 3, 4. So this is my third iteration. Now what are these lengths equal to, and what is my area? So those lengths there are going to be, so what I want is I want my distance here. Is that right? So I've got my, this has been halved to 4 root 2, 4 root 2, so I want this length here. If I have that length here, half of it should be 4. So let's get this length here, which is, again, a Pythagoras exercise. I've got these, they're 4 root 2s. So now I'm after this length here, which is my distance 2, that was distance 1, is equal to, that's squared, is equal to 4 root 2 squared plus 4 root 2 squared, which is 16 times 2, 32, plus 32, which is 64. So my D2 is 8. So that length there is 8, and half of it is 4. So that checks that off. Now I want the area of one of these little triangles here, which is, again, my area is equal to, well, it's getting busy in there, area is equal to right angle triangle, what's this length here equal to? I've just worked it out to be 4. Because that whole length there is 8. So that's 4. So it's 4 by 4, 16 divided by, so it's a half by 4 squared, which is 8. So I'm going to put an 8 in there, and that completes my square. My table. Now, so that's 4 marks. Now, B, the process described above is repeated. Find A6. So we're going to go here 4, 5, 6. We extend our table out, and we follow the pattern here that's been established. Now, the pattern is 32, 16, 8. We're halving to 4, 2, 1. So A6 is equal to 1. Now, that, for 4 marks, took me, I don't know, a fifth of the time that 4 marks took me. But there you go. A6 equals 1. Now, part C, consider an initial square of side length K. The process described above is repeated indefinitely. The total area of the shaded regions is K. Find K centimeters squared. Find the value of K. Now, I'm thinking this is going to be a pattern that goes through. And it looks to me like we're after the total area of the shaded regions. This plus this plus this plus this. This is a geometric series, and I think that's where it's heading. So what we should do here is we start with side length K. So what I thought here was that we'd start the process again, except this time not start with a 16 by 16, but start with a K by K. So that's K units all the way along there, and we get the square going, joining the midpoints, so that these lengths here are K over 2. K over 2. It's a right angle there. So if I go to my first square is under here, my xn is not 8, but it's K over 2. So I'll have a right for n 1, 2, 3. I'll start setting a little table up like so. And what I'm interested in here are my xn and an. Oh, sorry, they should have gone under there, shouldn't they? Okay, so xn and an in here. So when we start off with a side length K, then my first side length is K over 2 in here, and my first area, which is this area here, will be equal to 1/2 by K over 2 by K over 2, which is equal to K squared over 8. So K squared over 8 goes in there. Now my second square, which is this one here, that one there. Now I need to now know what half of this is, so I need to establish what my hypotenuse here is. So that length in there is equal to the square root of K over 2 squared plus K over 2 squared. That's what that's equal to. So it's a square root of K squared over 4 plus K squared over 4, which is a square root of 2K squared over 4, which is a square root of 2K over 2. So I've got now this length here is my x2, and that's square root of 2K over 2. Now my area, which is this area in here, that area in there, area there is equal to, remember this is now square root of 2K over 2, and as is that, so it's 1/2 of the square root of 2K over 2 squared, which is 1/2 of, so we're squaring this, we end up with 2K squared over 4, so we end up with 2K squared over 8, which equals K squared over 4. So I put a K squared over 4 in here, and that's going to be my A2. I beg your pardon, I've made an error here. This distance refers to the whole hypotenuse, so actually all I want is half of it. So I've got root 2K over 2. That is not my side length. It's root 2K over 4. Because I just want half of this. Right, divide that by 2. that represents that whole hypotenuse, so only 1/2 of it. So it's root 2k over 4, and if I then use that, so I need to change, this is root 2k over 4, if I just get rid of all this, then my area in here, my area in there is equal to 1/2 of root 2k over 4, root 2k over 4 squared, which is 1/2 of 2k squared over 16, which is 2k squared over 32, which is equal to k squared over 16. So that goes in here. So what we've got now, and we could go to the third one, but I think this is enough. What we can see here is that we've halved our value from k squared over 8 to k squared over 16. And what we can now assume is that A3 will be equal to k squared over 32. And we can assume that because that was the pattern from our previous example where we started with a 16 length. So the principle is exactly the same. We're just starting with k, but because of this halving process, our area is halved as we go through. So we can now assume that my geometry, it's a geometric series that starts with first term of k squared over 8 that has a common ratio of 1/2, and because my ratio is between -1 and 1, an infinite sum does exist, and it's u1 over 1 minus r, and that's what we're trying to find. Consider initial square, so the process described is repeated indefinitely, hence the infinite sum. The total area of the shaded regions is k centimeters. That's giving me an infinite sum. So this is my infinite sum k. Find the value of k. So therefore, all right, my infinite sum is equal to k, which means now I can put in my u1, which is k squared over 8 over 1 minus r, which is 1/2, and I can make that equal to k and solve. So times top and bottom by 8, and we get k squared over 4 is equal to k, so therefore k squared is equal to 4k, so therefore k squared minus 4k is equal to 0, and therefore k minus 4 equals 0, and therefore k is equal to 0 or 4. I have a feeling we can rule k equals 0 out because we initial square of side length k, we can't have, if k is 0, then we don't have a square at all. So I can rule that out. So therefore, k is equal to 4. That is my solution, and that completes the paper. I hope that's been of some use to you.